Boom. Okay, I'm already live. Alright, so I'm going to do a little bit of a different stream today because I want to do some programming. And I know it's not gaming, but it's fine. We're not going to play Minecraft today. We're going to do some coding. So currently, so I got, okay, so I replied to a Reddit thread like about a week or so back, and it was basically about Ascii image art. It was an animated like Ascii art of a fireplace. Um, like just a fire log in Ascii art. It's kind of cool. But I got onto commenting about how someone said it was basically impressive that this guy did about 150 frames of animation of it. To which I replied, it's not necessarily super impressive if he, or at least like it's impressive in a different fashion if he coded his own conversion from a set of images uh, into Ascii art automatically instead of doing them all by hand. If you did it by all hand, that's very impressive and quite a lot of tedious work, which I personally could definitely not do myself. But you, but it's not necessarily as impressive if they created their own basic converter that converts a set of image sequences into ASCII code. Then someone said, "Oh, but that sounds really complicated." To which I said, "It's not as complicated as you think. It's actually not as bad. You can easily create a basic set of encoding rules as well and create a file structure that allows for this too." So basically, this is me eating my words and saying, yes, this is something you can do with, I would say, relatively, like this is something you could read like a basic book on C and program in C without too much trouble. You might need like a couple months of programming experience if you like actually dive into it. I don't think it's necessarily practical for everyone to learn in 3 months, depending on what your living situation is or your circumstances. But as far as like the actual theory is concerned in creating this kind of a program, it's not technically complicated. And I guess the solutions to making this from a technical standpoint have been around for like a while now, because you're basically just making a sort of modified image file to make a Ascii Art Image File spec. So that's essentially what I'm doing, just to show you can do this. It's not hard, and I'm just going to make a basic Win32 command prompt application that takes in a bitmap file and converts it to an Ascii art thing, which has led to me having to learn the bitmap spec. Thankfully, it's not too complicated. I think some people are like, oh, it's kind of weird, but like it's honestly not too bad. So you can see down in the bottom right hand corner of the screen here, and directly below the YouTube chat and stuff, I have the spec, but I'll bring it up here just so it's a little bit bigger. So this is the structure of a bitmap image file, and if you've never seen something like this before, you're like, what the hell? How do I read this? What even is this? And I'll just go through that quickly for those who haven't seen something like this before and are like, what are all these blocks and squares? What is happening here? Okay, so bitmap image files are byte files. So the structure of it is basically just, it's a string of bytes. It's a binary file. So instead of being something more structured like JSON file where if you open it up in a text editor, you get a set of text with things in brackets and information in brackets. Instead, if you were to open this up, you would just get a bunch of nonsense if you opened it up in a text editor, because the text editor would be reading the bytes and trying to convert that into characters, which would end up being a complete load of nonsense. Although not as nonsensical as you think, because there is kind of a thing, at least the first 2 bytes would be reasonable letters, and that would be BM, because that's the signature of the bitmap, which is this square right here, the signature. So if we're reading this, basically each one of these squares, at least here, is 4 bytes long. So from the distance from here to here is basically 4 bytes. And while this is set up to kind of help you imagine that like the structure is like this all the way down and then this starts, in all technicality, if we go and open up a bitmap file, let me just open the one that I'm currently using. I'm just gonna actually I'll show you quickly the file that we're gonna be using as our test file. So this is a render of a dragonfly I created. I've made it like really small. It's 40 pixels by 80 pixels wide because I want to test conversion to be able to convert it to Ascii Art for the command prompt. So it's just easier to go low pixel count in this case. But we're going to be converting this into Ascii Art slowly. I don't know if I'll be able to get there today. It's kind of tedious, and I'm going through and doing some other stuff on the side as part of this project, so it's a little bit more than just writing. If I wanted to write a straight thing that just did straight conversion, it'd be a little less time consuming, but I'm doing some extra stuff on the side for my own personal use along with this project. But so this is the bitmap image of what you would see when it's like actual pixel count and what you would see in general. Now, if I open this in something different, it might actually be easier for me to just open my Hex Editor first and drag it into that. Ajax do you. Alright, so here we have this opened up in a hex. Now, I'm going to just go and drop this down to 4 bytes wide. Just because that makes it easier when I'm looking at the bitmap reference here. So you notice if we look at this, this looks a little bit more structured here. So you can see this BM here, these letters here. So these 2 bytes are the signature. Now the problem with kind of opening it in a Hex Editor like this is you don't get the same structure because you notice that there's 2 bytes empty after the signature. So you have to say, these 2 bytes must be like nothing. No. The next set of bytes in this happens immediately after, which is the file size. So actually, these 4 bytes here are the file size. And then it kind of ends up going offset because of that. So you have the next one being, well, I guess technically this is reserved 1 and reserved 2 bytes. I believe the reason they're reserved is in case the file size gets bigger than 4 bytes, but I haven't dove in too deeply into the actual like spec of bitmap, but like judging from this image of how it's spec'd out, that would be my assumption. That assumption could be blatantly wrong, and please correct me if it is. And then again, you have this, which is the next set of 4 bytes, which is the offset to pixel array. So that's basically saying from here, actually I think it's from the start of the file to the start, but it's basically saying how many bytes is in this section. So how many bytes are present from the start of the file to getting down here, which is where the actual image data of the file is stored. Alright, in a big array of pixels. So we'll get there eventually, but that's essentially what that is. Then you have the dip header size. Oh, okay. Then the next one is dip header size. So this is just how many bytes are here. Although it looks like it's... I'm not sure by this document if this number, or the dip header size here, is the number of bytes in this second section, or just the multiple of bytes that are here. Just because the way it points out that this bracket is here, so I might have to look at that into a little bit more closely before I can say for sure on that, but that's it's either the number of bytes that this blue section, this blue table takes up, or the number of multiple bytes, multiple of 4 bytes that the div header takes up. Not 100% sure. It kind of seems to, if it follows the same logic as the rest of this, with the brackets there, then it's probably the multiple bytes, but I'll have to test that out just to confirm. Then of course the next 4 bytes is the image width. The 4 bytes below that is the image height. It's self-explanatory. It's just a byte value of a decimal number that tells you how many pixels wide and how many pixels tall the image is. Planes and bits per pixel. I'm not sure what the planes is. I think that might be layers, but I don't know if bitmap supports layers, so I think that might have to do with something with because I'm not sure what that has to do with yet. I haven't looked into it because it's not super important for what I'm doing with an ASCII conversion, as far as I know yet. Could be wrong. We'll find out later. Bits per pixel is very important though, because that tells us how many bits we're using to represent the color data of each pixel. So this is, currently I'm using 24-bit, so this will be 24 in this case. But it essentially says how many bits we use per color. So 24-bit color and 8-bit color. This kind of gets confusing because some people will call 24-bit color 8-bit color because, and vice versa, because it's 8 bits per channel. So 8 bits for the red, 8 bits for the green, 8 bits for the blue. And then together, 3 times 8 makes 24. So you kind of see a little bit things. So like if you were going to a monitor that said it had 8-bit color, like monitors tend to say, oh, we have 8-bit color, when they're using 24 bits per pixel to represent color. That's why you kind of see, like, it's why if you go into like your color settings on the Windows, it'll say like, do you want 24-bit color or do you want 32-bit color? You know, it's kind of weird. So 24, I think 32 includes alpha. So it's 24-bit color with an 8-bit alpha channel. Correct me if I'm wrong on that, but that's, I believe, how it works out. Unless it's 10-bit color, or 10-bit per channel with 2 bits of 2 bits of like for error correction and stuff, like 2 parity bits. There we go. That's the word I'm looking for. With 2 parity bits, so 30 bits with 2 parity bits. But I believe 32-bit color is generally 8-bit color, or 8 bits per color channel plus 8 bits for alpha channel. Again, correct me if I'm wrong on that assumption, but I believe that's what it is. Anyways, so that's like one of the discrepancies. Why it makes it so confusing. So like a lot of it is just confusing because terminology is used in places, and if you don't know what that terminology is in that specific context, you get confused. You're like, what is this? There's so many different things. So that's another thing that leads to people think this is more complex than it actually is in practice, or at least in like practice of like designing it. So that's one thing to talk about. What else do we have? Then below that is compression. So this just indicates if there's any compression. I'm going to be using uncompressed bitmap images, and as a requirement for a compatible bitmap with this converter, you'll need to use uncompressed bitmap images. I just don't want to deal with compression and deal with the different compression algorithms that like could be possible within it. I'm not entirely sure which compression algorithms are available in bitmap, if it's a non-lossy compression format or otherwise. I believe JPEG is lossy, but like there's different techniques you can use for compression that are lossy or lossless compression. And compression is just a whole thing I don't want to deal with for this thing because whatever. I mean, if this is going to be ASCII things, they're mostly going to be small pixel size images anyways. So like the amount of space they take up relative to how much space you have on a modern hard drive these days is irrelevant, so whatever. We're just gonna ignore compression altogether. Doesn't matter. And if someone really wants to add that to the code base later on, they can go ahead. But for now, we're just gonna ignore compression altogether. Then image size. So as you can see, we can follow this red dotted line down, and you will notice this is the total width times height. So the total number of pixels that is in the image itself. So that number is useful to some extent. And you have X pixels per meter and Y pixels per meter. This is same thing as PPI. It's basically just for useful for print. So if you wanted to print off the bitmap image onto a paper, it allows you to just have the image file for print versus a screen, because it'll automatically do a screen resolution. It'll just map pixels to pixels. But when you're talking about moving pixels to something like a piece of paper, you have to designate how many dots per inch or pixels per meter, which is what this is. Somehow just to be like, hey, printer, I want you to do it at this like resolution, because printers can print at various resolutions depending on how much ink you want to use and all that stuff. So those are useful. I think in our case, that won't be necessary for the Ascii art, so we'll be able to just ignore that, because the whole point of it is going to be for computer-based anyways. Just again, if someone wants to add printing capabilities to this later, when I post the code on GitHub and all that stuff, by all means, I'll add that. But for now, we're just going to ignore that, just simplify the task, and also it'd be nice to have, but it's not necessarily important to have in this particular use case. Below that, we have the colors and color tables. So this is just again Byron. So how many color definitions is, so as designated by the purple bracket. So this is just the number of bytes that are designated to have a color reference. This is basically just if you have less than 8-bit or 24-bit color, whichever one you want to go with that. It's the whole thing, because 8-bit color is also a thing, but it's like so 8-bit color would be I think it's 3 bits. Wait, no, does that make sense? 3 bits per pixel. No. So it's 2 bits per pixel plus 2 parity bits. And one of those, actually no, it's 1 parity bit, 1 bit for, I think, nothing, 1 bit for black, and the other bit is for, and then 2 bits per color pixel, I believe is how that goes. Yeah. Depends on the system. You can set those things. If you don't want any parity or anything, you can get slightly more color data at the expense of possible corruption in the data. That's the thing. It's a lot of these things are like, how safe do you want your data to be versus how much information do you want to pack into those bits? Those kind of things, offsets and whatnot. So bitmap wants a color table because you can have, because when you have a color table, you can have less bits to represent colors, but you can still have the same options of colors of like something like a 24-bit color table with 8 bits per color channel, because you can map specific colors that you want from that 24-bit instead of having all of those colors accessible. You just, if you just need a specific range of those colors for your thing, like for a sprite, your sprite only needs those 16 colors, whatever, you can put those in a color table and just say, I just need these 16 colors, and then you just map those all of those colors to a color table of just which just allows you to represent those 16 colors in significantly less space that the system is still capable of understanding. think that's a pretty cool explanation of that. But yeah, so that's just all the colors in the color table is, and then what a color table is in general. Very quickly. Important color count. That one I haven't read into. So you don't exactly know what that number is. It might just have something to do with saying, hey, these colors you can't get rid of space-wise, but I'd have to look in deeper to see what that actually means in terms of the bitmap spec. So we'll just skip over it because I don't really know what that set of bytes is for, and I'd be talking out of my ass completely if I was trying to explain what that is. Then below that you have the red channel bit mask, the green channel bit mask, and the blue channel bit mask, and the alpha channel bit mask. Okay, so bitmap does support alpha channel, so in this case it would be technically, I guess. Yeah, so even though it says 24-bit color, it's technically 32 bits per pixel if it has an alpha channel. So I guess if it includes alpha channel, it's got 32 bits per pixel representing the color of the thing. Okay, so if bitmap supports alpha, then planes up here is probably the number of layers in the bitmap image. Then that's probably correct, my assumption from earlier about what the planes is. And it would explain why it's besides bits per pixel, because that's also an important thing to know if you're doing that. I think then also one of the restrictions is that the program will assume that everything has been compressed into one single layer, because at this point, if you're converting an image over to ASCII, like it should be flattened layer image over to text anyways. Honestly, I apologize if the exposure on the webcam there keeps changing. I tried to lock it, but it's just like, nope. That's what happens when I record in daytime, because my windows and the position of my desk at the moment. Alright, color space type. So those are just various color things. It's just saying like what color space it is. So if it's in Rec 709 or one of the other ones. Color space endpoints. Again, these are things that I'm like, I think. Then gamma for red, green, and blue. Gamma is a weird thing to me. It's because of the lightness. Like, gamma is like lightness, or like strength of the signal, but it's weird because it's like gamma's. I'm pretty sure gamma, like the point of gamma is to allow for its display on different kind of screens of brightness. So gamma is like a floating number that allows you to change what the maximum brightness is, if that makes sense. So it's basically saying like it's the limitations between 0 and 256 of how bright that difference is, right? So it's essentially what gamma is, I believe. I can look this up and see just how wrong I am, though. Gamma. Files. I'm going to find most closely responds to what we perceive as being twice as bright. Yeah, so if I'm just looking up and reading this is essentially what it is. So it looks like gamma is like a, so the input actual luminance and the output detected light, so eyes, camera. So yeah, so gamma is, yeah. So it's converting a linear to a logarithmic relationship, essentially what gamma does. So it's just making a linear light scale to a logarithmic light scale, because the human eye detects light in a logarithmic fashion, in the fact that it needs to have 10 times the light input from one to another to notice a major difference. So that's all that gamma is to some extent. So it's basically just converting a linear thing to a thing. This is why. So this image here is a lie. Sort of. It's confusing because this isn't actually what the linear thinks. So the linear one is actually more like this. It's just that because of the way our eyes like see light, we would basically yeah, it's hard to explain, but basically gamma allows us to capture more bright detail, like more lightness details, because it allows us to represent brightness logarithmically instead of linearly, so it allows for less wasted space in different areas, because we instead of storing the light in a linear fashion, it stores it logarithmically. Anyways, you can go and look it up more in your spare time if you want to. This actually seems like a pretty decent article, but yeah, it's a little bit confusing. Essentially just it compresses this, so like this maps it here, but this would map to like one, and then would do here, here, here. It's basically just saying every 10 times increments in brightness, this, then that. It's a whole thing. We are probably not going to care about gamma entirely, because I'm just going to be using 256 things, and because of the way I'm converting it, and the way I'm going to be playing it back with everything, gamma is all handled really behind the scenes by other things, in converting it from displaying things to the way I'm going to have it play back. It's not going to care, so we don't actually need to care too much about the gamma, unless it gets really weird. We'll see if I'll need to actually take into account gamma once we get the raw color pixel data and convert it over. I don't think we'll have to care about gamma as long as like the gamma is properly set beforehand in the image file. We just care about the colors. And intent, I'm not sure. ICC profile data, ICC profile sets. I think this is just the, this just has to do with what international standard it's using for color. And again, we won't care about this because we're making assumptions in the program, but it's going to take care of this for us later. Oh my god, it's been 30 minutes already. I've just been explaining bitmap file for 30 minutes. Wow. There's a lot of stuff. Okay, and then you get back down to the color definition type. We already went over this. Then a gap and thing. Yeah, and that all together goes into the pixel format. And then you can have the embedded color profile, or a path-linked file containing ICC color profile data. Yeah. So you can, that's basically just like you can embed the color profile within the file itself, so that the file can be offline in something and still have all the ability to translate what kind of colors it means when it says a particular set of bits in case it's using something different, because there's a whole bunch of different standards on how you can represent color electronically and stuff, so it's useful to have it embedded if you're using a weird one that's not necessarily the standard for things, so that other type can be like, hey, I represent my colors accurately. We're going to assume sRGB because this is going to be meant mostly for computer screens, so we're not going to deal with that either. All right, so now that we have spent like 30 minutes kind of explaining the basics of the bitmap image file structure and basics of image file structure in general, let's hop into what I actually have here programmatically so far. So you'll notice, you probably noticed this in the background if you're watching so far. So this is me just planning out what I need for my Ascii image so far. So this is me just going through and saying like, okay, I want a signature. It's just gonna say AI is essentially what this is. These are just the ASCII characters for AI. That's gonna be my signature bit, because ASCII image. Then we have the pixel array offset, so that will be the offset to the pixel array. And we're still going to call it a pixel array because it is a pixel array. It's just going to be a pixel array that has basically the color image data, and then it's also going to have an extra byte that is going to be the ASCII character represented to that. And we're going to, the converter is going to decide what that ASCII art character is. Actually, kind of based on the gamma. It might be based on the gamma. I might either base that directly on the gamma or base that directly on. My initial plan is just based on the actual brightness, based on the sRGB values that are coming into it from a 24-bit image. So basically how close all three of those channels are to 256. So what's the average brightness of each channel? And then that's going to map onto an ASCII character based on how many pixels that ASCII character actually takes up on the screen, because it gives a dithering effect, right? So yeah, so that's why you get like certain things. I'll go and ask you art image to explain this. Yeah, like this is a perfect example here. So you'll notice that it's like where it's darker in this image, they have characters with more pixels in order to get that denser, dithered feel and look. Same with this heart. You can see how they use the percentage signs and stuff in here in the heart to get that darker, and then just dots everywhere else to give it a lighter perspective. So we're going to be determining the character based on the relative brightness of the pixel. And then we're going to also basically be adding character, and there's going to be an option to be able to convert it just into black and white, like these ASCII character art stuff, or the ability to convert it into a color version. Is there any color? Yeah, so as you can see, something like this, although this kind of, that one's a little bit cooler. You can see the darts and stuff. So I'm not sure exactly on the algorithm. The algorithm on that section might change depending on once I actually get a basic one implemented and just see what the results are, to see how I attribute the ASCII characters, because I just need to write a basic algorithm just to see how good just a rough translation over that actually looks, compared to some of these more impressive ones that someone went in and did by hand and like actually consciously chose which ASCII character to use to represent that pixel to get like the best shape and stuff from the picture, because this is a more generalized program in converting images over to ASCII art. It's going to be, it'll be probably a little less good at replicating shapes than someone doing it by hand intentionally. But the idea here is just to make it like super easy to convert a large amount of image files that are in like an image sequence, so you can get an Ascii Art video, or just very quickly get an Ascii Art image from a bitmap image. So that's kind of the intentions of the plan here. So we'll get there, and then we'll decide if it's worth like going back and like algorithmically changing it or doing whatever changes are necessary, depending on what kind of quality we actually end up getting out of it, just based on the algorithm, the basic algorithm that we're going to implement in the first place. And we'll revise from there. Okay. Cool. So let's just bring that back up here. And actually, let's just go through the code that I have here set up. So we have the main file. So this is the main file. This is just set up to take arguments so far. So this is being written in C++, by the way. C++ command prompt. Just because I like C++, I can write like C, and it's just easier for doing this bytecode stuff and whatnot. It's just better. In this particular case, I can do this in JavaScript too, but it'd be more of a pain in the ass, especially for opening files and stuff. It's just easier to do this in C++. So we have, this is a class that's setting up interface utilities. This is basically just so, I think this compiles currently. I don't think I've broken it. Yeah, cool. It's currently running automatically because I have commands going into it, but the interface utilities class basically just allows me to type in commands afterwards. Oh yeah, I have it at a breakpoint. Yeah, because I was trying to figure out, I was trying to get this to convert properly, so it is actually giving me the proper decimal number of how many bytes were in the file size. So that's why I had a breakpoint in there. What was the last thing? So right now I'm currently writing the stuff to actually deconstruct the bitmap header and be able to take from that the information that is necessary to be able to convert it into an Ascii image in the first place that is accurate and representative of the original file itself. So I'll just close that for now. And you can see this is the code that's actually responsible for doing that so far, and also up here as well. Really, all of this code here. Yeah. So this is basically checking the flags. This just checks the characters. So if I just run this again, just so I can get the command prompt open. So the current command structure of this, commands that will be passed to it, is the convert command. There's a couple commands because this will be a convert command and a playback command because I want it to be able to play back at least black and white and 16 color versions, so 4-bit color. Actually, I think it's less than that. Yeah. Well, 4-bit color under the presumption that it's the 24-bit color, if you're wording it that way. Just because command prompt can't display text in more than 16 colors. You can only use 16 colors at a time, including the background color of the command prompt. So I think that might actually change because Windows has been touting new upgrade to command prompt in general, but for now, until that actually gets released and sees the light of day on Windows, we're going to go and assume that we just have what we have currently, 16 colors available, black and white, but I will still maintain the ability to convert it to proper full 24-bit color by creating a JavaScript-based player that just runs it in an HTML page, so someone can just run the HTML page and then open the file from that, and then just have the file in there, and it'll just be like, hey, look at this file, cool, get the information out of that, and if they want to run it on a like server or something, basically. That's actually probably going to be more of a pain in the ass than doing the black and white and the 16 color version, but what can you do? It's actually maybe probably the longest part as far as writing the playback thing. But it is possible, and we will achieve it eventually. So the convert, and then you have the thing. So this is just a flag that I have to note that if you're just converting a single image or a sequence of images, just that way it knows that it's going to be converting more than one image, and instead of expecting a string here with the path to a specific image, it's just looking for a folder path so that the program itself can go look at that folder and find all the files that it's going to be converting. And then at the end you have -G, and that is for dash grayscale. So there'll be a couple different images. So that's just the flag that's going to be there for determining what color profile you want the image converted to. So if you want it just in black and white, or 2-bit or 1-bit color, I guess. So basically being either a white or a black pixel, or if you want a few stages of gray, so you just want to keep it black and white, but be it more gray style, so you have a little bit more of a gradient between white and black, and or if you want it to actually be in color. Yeah, and then that's pretty much it. I thought about including arguments for resolution, but I kind of, like when I thought about it, it kind of just seemed like an excessive use case, because I think it's easier for someone to just decide the resolution they want beforehand when they make the original bitmap image in the first place to convert into Ascii art, than for someone to, or then to convert it convert it from the resolution at the time of conversion, because it's just like, I don't need to reinvent the wheel kind of thing, you know. It's, if you can just set it to the resolution you want beforehand, and that's just easier for me, and it's frankly easier for other people in the first place. So I'm gonna not bother with that, and it's just gonna use the resolution of the bitmap file that is put in the input, and yeah. And I'll just have like a README file associated to be like, hey, this is the recommended resolution for if you want to make a ASCII image that gets played back in the command prompt, or if you want to do it in the browser version, etc., etc., etc. Because you couldn't necessarily put a 1080p image in here. I mean, like, you could, but you gotta remember, when you're converting a single pixel to a character, that character actually takes up more pixels than the pixel array itself. So any image you're going to put in here is going to become much larger, or it's going to take up much more pixels depending on the font that's like used, or like the text that's actually being used here. So again, you have to take that into account with the resolution that you're using. So I'll just continue on. And that's why I'm using an 80 by, what is that? Oh, it's just because I was doing weird stuff, so I needed to type something in this command prompt. So that's why I'm using a very small integer, 80 pixel by 40 pixel image, and that is specific because that's the amount of characters well, 80 characters is about the width. I think it's close to the width of this. I think it's a little less actually in this case, but like of a standard console size. I think this is thing, but the standard console size is like slightly lower. But it's about the number of characters that goes across in a console, and about the same height wise as far as characters are concerned in the console as well. So that's why I'm using that resolution specifically for this. And you notice I have here just in the output, it gets 24 bits, but I have it set to just tell me how many bits that is per pixel, just so I can have both there for reading. It just makes it easier. And then of course that file offset to the pixel array, the number of bytes. Okay. I believe that is about it. You'll notice also that this, like, I'll still use interface utilities, but over here I'm getting the args here. So I'm checking certain arguments in here and then calling the different commands here. Check the past ones and things. So doing slightly different between manual mode and thing, because manual mode takes in kind of string there. That's the whole thing. Hey Trifo. I'm not doing Minecraft today, I'm doing programming. And these are just some printouts for such, like printing out the command input and printing out the initial text you see on the screen. Okay. This was just really doing the binary bytes, so I don't remember. So I have just a easy visual cue of what that is. And some information there. So byte 1 being, hey, the color table is present. Just to make it a really easy check. I know it's kind of a waste to use an entire byte for just a single like Boolean condition there, but it's a byte, and in current modern things like 8 bits, whatever, it's fine. It's not a lot of data for that in this case, in the scheme of things, considering the rest of the size of the image. And then the byte 2, and then the second byte just shows the color table byte index, so just where it starts. Which I guess is technically handled by the header size. And I see why that's like slightly different. Okay, interesting. Okay, in that case then I am going to include the file size. Because I understand a little bit better than when I was making this thing about how the bitmap image is. Just going through and actually just explaining that to other people is nice. Actually, a good rule of thumb for something is it's nice to sit down and just try to explain it. Like the rubber duck method of IT consulting is talk to the rubber duck. If you can explain it to the rubber duck, then you have a better understanding of what you're actually doing. Rubber duck knows all. Alright. So what the file size? I guess reserved. Because if I do this as if I convert an image sequence into a thing, and I'll have like frames and stuff, and make this as a both image or an image sequence thing, I need more space to cover a larger file size. And then pixel file offset to pixel array. Yeah, so pixel array offset. Tomato, tomato. Okay. And this is actually interesting here. So you notice how they separate these header things. So this header will always, oh, all right, that's not visible too. So notice in the structure here, how they essentially separate these two pieces of the header. So this will always be the same in every single bitmap header, whereas this will change depending on which version of bitmap spec you are using. That's why it's bitmap version 5 header. So this is the spec for the v5 of bitmap, and that should be important to note. That way that this section can change as time goes on for incorporating needs of other things, and it's easily to change out something, so that's kind of important to know. I don't know what DIV stands for in this case. I want to say data something, but that could be completely wrong. Okay, so I'm thinking I'll do a similar thing with how the bitmap is here, because that's just a smart thing to do. So, yeah. Data meta header size, and that'll be in Is it easier to do that in bytes or multiples of 4 bytes? I guess it'd be easier to do in bytes. Yeah. Yeah, I think that makes the most sense. You know what? No, I'm gonna go for this being number of bytes, and then each one of these being a byte offset, and then just being able to refer to those as which number of bytes it is. You know, that makes the most sense. I think that's a more useful way to do it, because then I can just have more things that are set maybe to only 2 bytes if they only need to be, and such. And I can just say, hey, go to here in the file, in the byte file, and read from this byte to this byte. to get the data you want. That's just easier for me, thought-wise. Guess we'll add image size. Like, we can put it in. There's no reason not to. Again, we don't need X pixels or Y pixels per meter. Last batch of this. Number of colors in color table. Four bytes would be more than enough to hold that. I don't really care about the important color count in this case. That's not a huge deal. Yeah, so that's a bit mask. It's kind of strange. So I think the point of it, because you have 4 bytes. Why does bitmap have 4 bytes for the bit mask? What does it need 4 bytes for? Is it just 4 bytes because it fits the space? No. Let's represent that in here. Let's go to that. So that is 2 bytes, 6, 10, 14, 18, 22, 26, 30, 34, 38, 42, 46, 50, 54, 58, 62, 66, 70, oh crap, I went right past it. But yeah, so if I go to like a 64th, so 4, 8, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, I think it might actually be slightly better to put this into 2 bytes. Signature was 2, 6, 10, 14, 18, 22, 26. I'm getting hungry. I might go take a break and eat. Yeah, I'm gonna go take a break and eat because I am tired and I can't add that up in my head. And if I can't do simple addition like that, I'm very tired. So I'm gonna take a break. I guess that's an hour lesson. Like the first 30 minutes of that is basically a crash course in bitmap images and how images are actually created as byte files. It's still useful information. So I'm gonna hop off and I will continue this in another live stream for now. But that was basically just kind of the introduction, we'll say, in kind of what I'm trying to do here with this code base, what the goal is, and a little bit of an introduction into how bitmap images are stored and created, and how just image files in general are stored, and how a little bit about how binary files work too. So it's a little mishmash. That's a lot of information in 30 minutes to an hour, especially if you haven't run into any of that before. So yeah, so I'm going to end the stream there, introduction, and I'll be back and I will continue making live streams around this code. And yeah, all right.